don't know if anyone's looked at the clock lately, but do you know what time it is? Time for calculus. What? Oh, so exciting. Here we've got the graph below represents position S of t. Okay, I'll go with it. This is S of t. If you need to write really big that this is the position function, you do what you need to do. This is S of t. So really carefully, I think some people even on the last test, what got them was just not knowing I think it was f prime that was given. It's really important to know which one. So this is the original function. This would be like f of x, the position function. And then I have to think through, okay, what were those connections that we made before? If I take the derivative of position, I get velocity. So the first derivative is velocity. The second derivative is going to be acceleration. So let's think about that. Okay. So in this one, it says, at which point is velocity is equal to 0? So velocity, I want to know when velocity is equal to 0. So before I even look at this graph, I need to think, okay, what does that mean? What are the connections here? Remember, velocity is the same thing as s prime of t. And now I know, oh, the slope of the tangent, s prime of t is equal to 0. So I'm going to say the slope of the tangent, s prime of t would be equal to 0. When would that happen? Slope of the tangent, if I made a tangent line here, if I made it here, this is when I've got horizontal tangent lines. So my answer is going to be B and D. And my reasoning as the position function, so S of t, has relative extrema. Therefore, S prime of t is equal to 0. And this is kind of, therefore, I'm going to say and s prime of t equals 0. Only because if I say therefore s prime of t equals 0, that's not always the case. S prime of t, like, if this was, I could say s of t has relative extrema and has smooth curves, therefore s prime of t is equal to 0. I can do that. And is differentiable, you know, like there's a smart curve. Therefore, s prime of t is equal to 0, because there are some times when there's a sharp curve or a sharp turn that the derivative would not exist, but this one we're asking when is velocity equal to 0. So I know this is being nitpicky, but that's what I do, so that's okay. So relative extrema and is differentiable. S prime of t was equal to 0. So nice smooth curves. Still getting into this though. Okay, this one's a little bit harder. When is acceleration equal to 0? So I'm going to write over on the side, acceleration would equal to 0. But we have a graph of s, so the position function. How is acceleration related to position? The derivative of s would be s prime, also known as velocity. The derivative of velocity is acceleration. So we have to go to the second derivative of position. If I want the second derivative to be equal to 0, second derivative is all about points of inflection. So the points of inflection, or I should say, second derivative is all about concavity for the original function. So I need to look at the places where s of t is changing concavity, so has a point of inflection, and I can write changing concavity at, and then where would you think that happens? So look at the graph. Where does this look like s of t is changing concavity? Did you say A? I did too. And C. And I would also say, do we know anything else? It's kind of hard. You might not even be able to say this. So you could potentially say A and E. But you know what? I might just leave this with C. If you said A and E also, you could totally argue this because this graph is not precise enough, but I can't really tell if it's changing concavity or not. In C, I'm changing from concave down to concave up. So S of t has a point of inflection, changing concavity at C. Therefore, A of t is equal to 0 at that point. Okay, where is velocity positive? So again, don't look at the graph yet. Just think, okay, velocity is greater than 0. What is velocity? S prime of t is greater than 0. So the derivative, the slope of the tangent is greater than 0. Where is the slope greater than 0? Well, s has to be increasing. So from negative infinity to b, and from d to infinity. And I already put a lot of these things here, but this is all good stuff to be writing. And the reason is velocity is positive. And you want to say something about s of t because that was what was given, not just s prime of t is greater than 0. So you'd say as s of t is increasing. Try these remaining ones if you haven't already, and then go through and fill in your answers with me too. On what intervals is the particle's velocity negative? So I want velocity is negative. That means s prime of t is less than 0. This would be happening when the slope is negative, so from like b to d. And the reason, because I have to use s in my reasoning, velocity is negative when s of t is decreasing. When is particles acceleration is positive? Okay, acceleration is talking about the second derivative. So if I've got acceleration, if I want that to be positive, that means s double prime of t has to be greater than 0. Think about it. S double prime is greater than 0. What does that mean about s? S of t is concave up. So if I want acceleration to be positive, acceleration is positive on the interval. Okay, now I'm looking where s of t is concave up, looks like a smile of some sort. Let's say C, and if you said E was a point of inflection, then you would only go to E. If you said C and you didn't include A or E as a point of inflection, you could just go C to infinity. So your answer might change slightly depending on whether you used E or not. So acceleration is positive and positive. And that's my reasoning already, that S of t is concave up. Okay, acceleration is negative. That means S double prime of t is less than 0. Acceleration is negative when S of t is concave down. So that's my justifying. S of t is concave down, and I'm looking, and again, this would depend on whether you used A or not, but I didn't, so I didn't include that as a point of inflection, so I'm saying negative infinity to C on that interval. Okay, check your answers with mine. If there's anything that you need to go back to get the explanation. If not, let's move it right along. Every time I think that, by the way, moving right along, I think of the Muppets and Kermit singing, like, moving right along, footloose and fancy free, and they're like in their car, whatever. And he's in with, what is the bear's name? Fozzie. It's good times. Okay, the 5 commandments of particle motion. This is not one that you need to memorize and be like, what's the first one? What's the second one? But these are things that are really important. But these two could really go together. The particle is moving to the right when velocity is positive. So you can think about it as position is increasing, but if a particle is really boring and only moving left and right, position increasing is the same thing as a particle moving to the right. So really important, velocity is positive to the right, velocity is negative, that means the particle is moving to the left. Here's the new stuff. The speed of a particle, so this is slightly different than before. Speed is the absolute value of velocity. So if you took physics before or doing it now, speed is the absolute value of velocity. So it doesn't matter whether the particle is moving right or left, the speed will be the same. It's just the velocity without the direction. It's always going to be positive. And here, the speed of a particle is increasing when the velocity and acceleration have the same sign. So this is sometimes hard for people to get because this is a new topic for lots of people. So velocity being positive, the sign matters. If velocity is positive, so velocity is greater than 0, there's a force being put on the object to the right. It says v of t is greater than 0. It's really hard to see there. If acceleration is positive, that means you're speeding up. You're going to, I should be really careful with that, take away that speeding up. If velocity is positive, that means the particle is moving to the right. There's some force acting on the right. Acceleration is the rate of change of velocity. If acceleration is positive, this is saying that there's some force like in the right direction. Here, if I've got velocity is greater than 0, acceleration is greater than 0, I am going to be saying the particle is speeding up. The speed is increasing. So if they have the same sign, speed is increasing. But there are some instances, oh wait, I could also do this. If velocity, let's say, is less than 0, that means there's a force where the particle is moving to the left. Velocity is less than 0. And acceleration is less than 0. There is a force being put on the velocity, also moving to the left. So same sign, we're talking about speeding up. The speed is increasing because that direction matters. Speed of a particle is decreasing when velocity and acceleration have opposite signs. So let's think of velocity being positive. That means the particle is moving to the right. So we've got this, the particle is moving to the right. But acceleration is negative. That means like there's some force being put on this to the left in some way, and remember the rate of change. So it doesn't mean the particle is suddenly moving to the left. It just means that now this particle is not moving to the right as quickly. The velocity is the one that controls the direction of the particle, but this acceleration, think about it, it's the rate of change of velocity, so it's applying a force. Like in this case, this is like particles moving to the right, but acceleration is less than 0, you're putting on the brakes. You're slowing down. The particle is decreasing its speed. Acceleration, so acceleration, velocity and acceleration have opposite signs. Let's say, sorry, I started to go here and then didn't actually write it. Velocity is less than 0. That means the particle is moving to the left. So this one, I can say up here the particle is moving right, the particle is moving left, because it's always based on what velocity is doing. Right, left. But acceleration is the rate of velocity. So if it is greater than 0, I'm suddenly putting a force. It's not moving the particle to the right, but suddenly it's taking me down, like it's putting on the brakes. So I was going in the left, or the particle was, that super boring particle was moving to the left. Acceleration, if it suddenly has a positive, if the particle has a positive acceleration, that means there's a force being put on this velocity to the right, which will slow it down. So in this, we have the opposite sides. This is when the speed is decreasing, or we can say slowing down. There are some times when velocity equals 0, but the acceleration does not equal 0, and the particle is momentarily stopped and possibly changing directions. So this is possible. Think about if you, again, this is a very boring particle. It either moves left and right or up and down, but we can think about a ball being thrown into the air, or even, let's say, this pen. There is a moment at the top when it's changing directions that it stops, and then it comes back down. There's still an acceleration on this pen at that time. It's just momentarily stopped. So if you see something where like velocity is 0, but acceleration is still doing something, that's a-okay. Okay, let's use this now. So suppose velocity of the particle is given by this function. So we've got this function here. Nice. Actually, I already put this in my calculator, so you might want to go get your calculator to do that. Where t is measured in minutes and v of t is measured in inches per minute. That's nice. They're giving that to us already. T is measured in minutes, so it gives us this rate of inches per minute for velocity. So we're starting with a derivative. We're starting with a rate already. We've got velocity. Find the values of v of 3. Okay, nice. So here's my graph. So I already put in this function, and it says where time is greater than 0 or equal to 0. In most cases, that's what you're going to see. I changed my window here to go from -1 to 5, and then for my x-min, -10 to 100. For my, my y-min. Y-min is -10, y-max is 100. And I changed this because it was really hard to see if I just had a standard viewing window. If I want to just go to my graph, now I can see some stuff going on, that's good. If I want to find the value at 3, remember this is the graph of velocity, use second calc, value at 3. And I can see, whoa, that's really big, but is that okay? Sure, a particle can be moving 245 inches per minute. Why not? So v of 3, I'm looking at this value down here, is 245. And my rate for velocity was already given in inches per minute. V prime of 3, so let's just think through what this means. V prime of 3, the derivative of velocity is acceleration. So that's going to help us when we're doing this in a minute and we're trying to see what's happening with this particle. But the derivative of velocity is acceleration. So if I go down to dy dx, that's my option 6. And then you just type in, it looks like nothing's happening, but you just type in 3. I see that the derivative is 119. And you could have done the product rule here and then substituted in, that would have been just fine. This would be inches per minute, because this is this slope. So think about inches per minute would just be the y value. Rise over run. Remember the x-axis was given in time, so this would be minutes. Based on these values, describe the speed of the particle. So right now I've got a velocity 245 inches per minute at 3. So at 3 seconds, or 3 minutes, I'm sorry, the particle is moving 245 inches per minute. Which direction? To the right, which it doesn't ask about that, it just asks about speed. Here I've got this positive value of a positive acceleration of 119. Because these are the same, that means that the speed of the particle is increasing. And so I'm going to write the speed of the particle is increasing. When t equals 3 minutes, my reasoning is just going to be as v of 3 and v prime of 3, or you could say a of 3, have the same sign. You don't even need to say they're both positive, because I can see that over here. I already found my answers over here and I can see that. So you can just say same sign and then move on with your life. Okay, on what intervals is the particle moving to the left or to the right? So let's think about which one of those is influence. So speed is influence, where you have to know velocity and acceleration. But just for direction, the only thing that you need to know is is velocity positive? The particle is moving to the right. Velocity is negative. The particle is going to the left. And so I want to figure out, well, where is velocity? Neither of those things, neither right nor left. It wouldn't be greater than 0, it wouldn't be less than 0. When is velocity equal to 0? And I can see if I want 0, and I've got t plus 2, t plus 4 squared. I just copied down velocity from right up here. I see that when time is -2 and time equals -4, that's when the particle has a possibility of changing directions. I can make a chart, and you're like, wait a second, time can't be -2, because I saw time could only be greater than or equal to 0. And time can't be -4. That doesn't make any sense. So if I were to make a little table here, and I want t to infinity, and I checked my velocity and I wanted to see the sign is velocity positive or negative? I shouldn't say t to infinity. What should I have said? 0 to infinity. Because it's at time, anytime time is greater than or equal to 0. Whatever this is going to be, because I can see the only possible changes are at -2 and -4, which aren't included because t is greater than or equal to 0. This is going to be the same sign the entire time. So pick your favorite number. 572. Crazy that we thought of the same one. 572 plus 4 squared, still going to be positive. Times 572 plus 2, positive. Positive times positive is still positive. Which way is this particle always moving? To the right. So I'm going to say v of t is greater than 0 for all t is greater than or equal to 0. So I'm showing all of this work. So I'm showing all these things that I know. The velocity is greater than 0, moving to the right, less than 0, moving to the left. So this helps me think. That's also justifications. And I'm showing my analysis here. I'm showing that I considered setting the velocity equal to 0. I found these values, but then I knew that t had to be greater than or equal to 0. Showing so much stuff. So v of t is greater than or equal to 0, or I'm sorry, v of t is greater than 0 for all t is greater than or equal to 0. Therefore, the particle is always moving to the right. We did it! If you have any questions, please let me know. I appreciate you. I appreciate you working. You're a big deal. You should know that. Thanks so much. Bye!